get a view of the atom at that time. But this is what they all, of course, wanted. So in 1947, he started his experiments. And then suddenly he had the idea to use a complete different way of reconstructing this, the object. And he said, what if we would have a light which is coherent light, as laser light is. Maybe I should explain this a little bit more. Coherent light, coherence of the light, of a laser light especially, is the phase of the light wavelengths remains the same on a special distance. This is the so-called coherence length of the light. Laser light is a light of just one single color, one single wavelength. We use in holography, we use a red helium neon very often, which is at 632 nanometers wavelength. So this light is meanwhile quite stable for centimeters, and with additional tools for meters or even dozens of meters, coherent. And this is the fact which is required to make it possible to store 3D information in highest resolution in a photographic plate. Actually, this is what it is. A hologram is a special photographic plate, but with absolutely highest available resolution. So he had the idea, if we have a light which is coherent, and then split it into two halves, quite easy. You have a laser light, imagine the laser, which was not invented that, but later on it was possible. Take a laser beam, you put a 50% mirror in an angle of 45 degrees inside. So half of the beam is going through, half of the beam is going to the other direction. Now you've got a so-called object beam and a so-called reference beam. What's going on here? Ah, computer. Ah, okay. Okido. So I'll have it here. This is good. I can go on here. This is an extract. He had the idea. This is the basic principle of a holographic mastering. We've got a laser. Here you've got a beam splitter. Then half is going through, half is going away. Let's go see this one. This is going through. This is the reference beam. The reference beam is just, here's a mirror. There's a lens opening up the beam. And then here is the photographic, let's say, holographic plate, because it's a very special photographic plate. Later, some details about that. So this is used as a reference only. The information, the 3D information of the object being reconstructed is only stored in the object beam. So you use the other beam, which is called object beam, also mirror, also lens, wide it up, and direct it on the object. The object reflects the light, as usual, and so what happens is, in the film, in the plate, we've got like a window which stores the light wavefront being emitted from the object by an interference pattern. You know, because the coherent light allows us to exactly define the light differences, which is the information of the object, the light which is reflected from the object. You know, this is, imagine the master plate is when it's after exposed and developed, it's like a window inside of the master lab. You can see through that window and see the object. This is exactly what that hologram is, to understand the basic principle. It's an interference pattern storing the light wavefront being reflected from the object you want to do a hologram of. It's a little bit complicated in the beginning, but it works, obviously. So this is the basic principle. Funny is, he was not capable of testing his forecast because laser was not invented. He had invented some of the oscilloscope and the mercury steam lamp, I think it's called. In German we say Quecksilberdampflampen. So this is the only light he had available in flash form at that time, because laser didn't exist. It was in the head of some people. So this is the interesting basic thing that Gabor invented holography while he wanted to modify electron microscopes, but he couldn't prove it. So what happened is he published his papers. Yeah, he published his papers the first time 1948. At that time, maybe this is also important to know, at that time he didn't use the two-beam system I've just described. There's another way, much easier. Couple of years ago here at the Congress, we made a workshop and did at the toilet here around the corner, we did holograms using this inline hologram system, which is using just one single beam which interferes with itself. It's a different geometry, but it also works. Important is that the light, coherent light, interferes with itself, the own frequency, and within that interference we can store the 3D information. Quite interesting is also, you'll find it here on this website. You'll find the links to this Gabor lecture. I'd recommend to read that because it's explaining it very much and very good and very detailed. And Gabor was an interesting guy because he was quite skeptical about technology at that time already. He made a bunch of inventions. He had more than 100 patents at the end of his life, and a bunch of inventions which he didn't want to do. And he was quite skeptical about it and said technology is a big risk as well. So this guy is interesting to read a little bit more about him. So for all of you who are really interested in understanding how the basic different processes have to be handled during the production of the different hologram types, this page here is quite nice. I can click it here. I think it works. Here, these are quite experienced Russian holographers who offer lessons on holography, and this is hands-on guide explaining all types, the most important types of holograms. You can find it here. Link is on that page and on the papers, preceding papers as well. You'll find it there. Hologram with exposure times, recording, chemical solutions, and so on. So once again, in general, the hologram production and also the used chemistry is quite similar to photography, except first of all, the absolute highest resolution we can risk as well generate optically nowadays with this, as mentioned already, more than 15,000 lines per millimeter, not DPI or anything, really per millimeter. And because of that, and because of the wavelengths of the lasers we are using to produce that, we have to avoid one thing extremely, because otherwise it destroys the complete information and the hologram. We have, during the exposure, have to avoid any kind of vibration inside of the recording system, which is, the recording system is a lab. It's a lab. I can show you a link into the lab somewhere. Well, later on, I've got some. I'll show you. The more important thing is we record it in a holographic lab. Therefore, we build master tables, which are quite heavy, 2 tons normally, our last one, because of vibrations. Avoid all kind of vibrations. If a car is passing by, you've got serious problems already during the exposure. Physically or mathematically, it's quite easy to calculate. You may not have a fourth of the wavelengths of the laser you are using. So we use, let's say, helium neon 600 or argon or krypton laser. They have 488 nanometers wavelengths. So let's say 500 nanometers wavelengths of this is green, typical green color. When we have a vibration inside of that system during the exposure of a fourth of that, which is 125 nanometers vibration in a room. This is nothing. This is like a half a degree temperature difference between there and here. Speaking, no chance. No speaking during exposure. So physically we do it by, no, this is coming here. Here's the introduction about a laser first of all. Physically we do it by setting up the system, then go outside, drink a cup of coffee or whatever. And this is the so-called settling time, which is needed. It's like 50 minutes, 20 minutes, something like that. So get the complete vibration out of the damp, all vibrations out of the system. And then for remote controlled, next room, got a button, press the button, shutter opens, laser, shutter closes, exposure. Then we have the exposed photographic plate. The emulsion in the holographic plate is just, or got its maximum sensitivity in the ideal case in the exact wavelength you are using. So we use a krypton laser, 488 nanometers. This is exactly the emulsion. This is the highest sensitivity of the emulsion. In general, this is nothing else but black dots we are producing, but in an absolutely high resolution, which is finally, after having developed fixed and bleached, this is like in photography, the plate. This is now this little structure. You can imagine this hologram as a structure of millions of like mountains, which are directing the light, every light beam, exactly like the object did it in the lab situation. So, first of all, the first hologram, how it was created, was in the early 60s. In 62, first Maiman invented the laser in 1960. This was the first laser in the world, ruby laser. And then in 62 at the MIT, Emmett Leith and his assistant Juris Upatniks, they remembered Garber's forecast of holography in 48 by using a stable, coherent light, which now was available. They said, there was this crazy old professor, and he said we could do 3D photographs. Come on, let's try it by pure curiosity. And that's what they did in 62. They set up the system in the lab, tube beam. They did the first time a tube beam exposure, which I showed the graphics here, the tube beam exposure, which is different to the inline system. This is here, this is the Denisuk system, but to the inline system. So they tried, and obviously it worked, and they created the first hologram in the world showing a model of train and bird. It's not here, the photograph. I forgot that, but I can show it to you somewhere else. Come on, I'll show it to you. Vielleicht da. This is very, very old page. I'm honest, but here it is. This is a photograph of the first hologram ever made. Real hologram, let's say, because Garber tried to make a hologram which was 3 millimeters with some names of Newton and so on it, and Fresnel lenses, but I can show it to you later. This is interesting, but it really didn't work at that time. It could not work. Okay, this is a photograph of the first hologram in the world. This is what they found in their archives, I don't know, old train model and a bird. It's been the first hologram in the world by Leith Upatniks, 63, 64 it was made. Okay, so this is what they tried out, and obviously it worked. So they said, okay, this was really the birth of practical holography in the early 60s. Then it went very fast. We had additional developments. Quite important is to say, first, this is also important for you to know. At that time, and also today, the hologram masters, we call it H1, hologram 1, are only viewable under laser light again. They are not viewable under white light, because they are made with laser light, and the reconstruction is, you see, what you see in a hologram is the reconstruction by using the reference beam of the light wavefront, as I explained, of the object being reflected. So you have to use, for master, viewing a master, transmission master, H1, you have to use laser light. By the way, this is the most exciting hologram you can see. It's unbelievable. Most of the people have never seen that. I've got one here. We can have a look later on. So this is a master, let's say, a plate like this. That big. I made some in 1986. I made